Okay, so today's notes are combining 7.5 and 7.6, solving exponential and logarithmic equations, and natural logs. And our content objective is to solve exponential and logarithmic equations, and our language objective is to use the correct terminology to explain how to solve logarithmic and exponential equations. So previously, we've practiced solving for variables when they're in the exponent, so we've used logs to solve, but now we're going to switch back and forth between solving equations where the variable is inside a log and vice versa when the variable is inside the exponent. So we need to be able to solve when variables are in either place in the equation. So our first example is going to be, or ask us to solve log of 4x minus 3 equals 2. So let's jump right in. Our first step, we need to get the variable outside of the log. So to do that, we're going to rewrite it as an exponential equation. So again, if there's no base written, it's a common log, which implies a base 10. So if I rewrite this as a log, or if I raise both sides to the power of 10, depending on how you think about it, I'm going to have 10 squared equals, so 10 to the 2 equals 4x minus 3. So I rewrote this as an exponential equation. Now I'm just going to isolate x. So pretty straightforward. So 10 squared is 100 equals 4x minus 3. I add 3 to both sides and I have 103 equals 4x. Divide both sides by 4 and I get x equals 25.75. Pretty straightforward. So if the variable's in there, first you must isolate your log. So we didn't practice this, but you isolate your log, rewrite as an exponential, and then isolate x. So let's do a quick check. I want you to solve log of 3 minus 2x equals negative 1. So try that one on your own now. I'm going to go over it. So first step, I'm going to rewrite this as an exponential, and I get 10 to the negative 1 equals 3 minus 2x. So we're going to have some fractions here because a negative exponent means I need to rewrite it in the denominator. So I have 1 over 10 to the positive 1, which is just 10, equals 3 minus 2x. I'm going to subtract 3 from both sides. So I have 1/10 minus 3 equals negative 2x. This, if you want to plug this in a calculator, you could, because you're going to use a calculator at some point anyways, but I'm going to do it out algebraically just for practice. So I have 1/10 minus 30/10 equals negative 2x, which becomes negative 29 over 10 equals negative 2x. To cancel the negative 2, I divide both sides by negative 2. Dividing both sides by negative 2 is the same as multiplying by negative 1/2. So I'm going to multiply both sides by negative 1/2, and I get positive 29 over 20 equals x. And if I simplify that or plug that into a calculator, get x equals approximately 1.4, or sorry, exactly, not approximately, exactly 1.45. Sorry about that. It's exactly, not approximately. So x equals 1.45. If you used a calculator earlier, that's fine, but do practice fractions at some point. They're good to know. All right, I'm going to flip the page. And the second one, we're going to go the other way. So we've practiced this before with more application problems, but we're going to do it a little more explicitly with some natural logs and a few other steps. So if I have 4 times e to the 2x plus 2 equals 16, I'm going to start by isolating e, or the base and exponent. We've done this before. So I isolate the base and exponent. So I have 4e to the 2x plus 2 equals 16. Subtract 2 from both sides. I have 4e to the 2x equals 14. I'm going to divide both sides by 4. And I get e to the 2x equals 3.5. And then you can solve using logs. There's 2 ways you can do that. We talked about them in our previous lesson. But we're going to solve with logs. In this case, ln. I imagine that I take the ln of both sides and I get 2x equals ln 3.5. So you could take the ln of both sides and cancel those. Either way, or rewrite this just as an exponential or as a logarithmic equation using base power argument, definition of a log. Either way, you end up at this point, and then I'm going to isolate x. So I get x equals ln 3.5 over 2. If I plug that into my calculator, I have ln of 3.5 divided by 2, and I get approximately 6.26. So x equals approximately 0.626. And that is my answer. So let's do two quick checks here. So I'm going to do quick check 1 and quick check 2. I have e to the x minus 2 equals 12, and 15 to the 3x equals 285. So try those both out. I'm going to go over them now. So I'm going to start this one, the base and the argument are already isolated, so I'm just going to start by solving using logs. So I end up, you can either rewrite this as a logarithmic using the definition of our log, or take ln of both sides. Either way, you get x minus 2 equals ln 12, because the ln cancels on that side. And then I'm going to add 2 to both sides, so I get x equals ln 12 plus 2. One thing, make sure you remember the plus 2 is outside the ln. You're not plugging that in with that 12. You don't need to put the parentheses, just writing it as plus 2 implies that it's separate unless you put parentheses around the 2, but just for clarity's sake, I'm going to put them in. And then when I plug that into my calculator, I get ln of 12 plus 2, and I get 4.48. So x equals approximately 4.48. And that is our first answer. The second one, it is also isolated. So there's two ways you can do this one. I'll show you both. So you can rewrite using our definition of logs. So you have log base 15 of 285 equals 3x, which becomes log 285 over log 15 equals 3x. And then you can plug that in and divide by 3. So we're going to divide this whole thing by 3. So you have log 285 divided by log 15, then divided by 3, and you get x equals approximately 0.696. The other way you could do it is take the log of both sides here. So you have log 15 3x equals log 285. You bring the 3x down, and you have 3x log 15 equals log 285. Divide both sides by log 15. And you have 3x equals log 285 over log 15. Divide both sides by 3, and you end up at the same point. So again, those are two different methods to end up at the same point, but you end up with x equals 0.696 approximately. All right, that's all for today. Make sure you write down any questions, comments, or concerns you have so we can go over them together. And that's all.